This was a GCSE exam question from a few years ago, and as you can see, it became quite famous because it was an unusual way that they'd asked this question. They hadn't asked a algebra probability question before, so as you can see, it went viral. We're going to see how to do it because since this took place, this has actually become quite a common sort of question. So you guys need to figure out how to do these questions. Let's read it carefully. It says there are n sweets in a bag. 6 of them are orange, the rest are yellow. Hannah takes at random a sweet from the bag. She eats the sweet. She then takes at random another sweet from the bag and eats that. The probability that Hannah eats 2 orange sweets is 1/3. We need to show that n squared minus n minus 90 equals 0. And there was a part B to this question as well. Part B asked you to work out how many sweets were in the bag. So let's start drawing this out with a tree diagram, because we know that there are orange sweets or yellow sweets. We know that she took a sweet at random from the bag and then took another one. So here is the beginning of my tree diagram. And it told me that the probability of her eating an orange sweet and then an orange sweet was 1/3. The probability of 2 orange sweets was 1/3. Now I know by the AND rule that the probability of having 2 orange sweets will be the same as the probability of the first sweet being orange multiplied by the probability of the second sweet being orange. So I need to figure out what these are. Now, it told me that there were n sweets in total, and 6 of them were orange. So that means the probability of it being orange, that the first sweet being orange, will be 6 out of n, however many sweets that were orange out of the total. For the second sweet, it told me that Hannah eats the sweet. So that means that there would only be 5 orange sweets left once she's eaten the first one. In terms of the total sweets that are left, well, there was n to begin with, and she's just eaten one, so there is now n minus 1. So the probability of the first sweet is 6 over n. The probability of the second sweet being orange is 5 over n minus 1. So if we substitute those into our rule down here, we have this. So this is the probability of the first sweet being orange, this is the probability of the second sweet being orange, and when I multiply them together to work out the probability that both of them were orange, I get 1/3. Now we can times these fractions together easily by multiplying the numerators and multiplying the denominators to get this. And now I'm just going to do a little bit of algebra. So I'm going to multiply both sides by 3, and then I'm also at the same time going to multiply both sides by the n minus 1. So bring this up here and bring that over there. So 30 times 3 is 90. 1 times n minus 1 is n minus 1. I am now going to expand these brackets and take 90 away from both sides, and then that is, just bring the question back here, you can see the same thing as what we were asked to do. So we've answered part A of this question. And like I said before, there was a part B, which was to work out how many sweets there were in total. Remember that n was the number of sweets in total, so if I factorise that equation I had before, so that's just factorising the n squared minus n minus 90. So 2 numbers that multiply to make minus 90 and add up to make minus 1, minus 10 and plus 9. Then I can see that either n is going to be 10 or minus 9, and obviously you can't have minus 9 sweets, so the answer was 10. There were 10 sweets in total in this question. So there we go. So the key thing there with this question is don't be afraid to include algebra in your tree diagrams.